Hello everyone. In this tutorial we're going to see how you can define Altair Access Desktop as a solver execution script within HyperStudy to leverage HPC capabilities to solve any kind of problem, for example design of experiments or optimization in HyperStudy. Before starting, I want to mention that in order to use Altair Access as a solver execution script, first you have to have installed in your local machine Altair Access Desktop as an application and connect it with the cluster that you have access. Before starting setting up this problem, first we need to define it as a solver script. To do so, you have to go to Edit, Register Solver Script, and I will add a new one. I will call it Access Desktop Test. I'll press OK. And as a path here, you have to go to the installation path of Altair Access, and you will find a file called exec bin command line, and you need to find an executable file called pass-submit.exe. I will copy this path and I will go back to HyperStudy, paste it here, open, OK, and now I have defined Access Desktop as a solver script. Now I need to define a resource file, which will be in this case a hypermesh session. As a solver input file, I will just call it bikeframe.fem file, which will be the input file for our solver. And here, if I scroll down, you will find the new solver script that we have created. And then I need to define some input arguments for the solver. If you give it a few seconds for it to load, you'll find all the available applications that you have in your cluster. And for this example, I will use OptiStruct. And first, I need to define the input file, which in my case will be this fem file. I will just copy and paste it here. And then if I go to solver arguments, press OptiStruct, you will find some required arguments that need to be included for the solver to run, for the HPC to run, and some optional arguments. And yeah, I will write these arguments here. I will just copy and paste them here. And after I have defined all these arguments, one thing that I want to mention is that in primary file you need to specify again the fem file as a name and then the relative path, which will be dot and slash. I press OK, and if I hit import, I will need to define the variables, the design variables here from the hypermesh session. As you can see, the input variables have been defined, and in the test model I will hit run definition, and some messages will pop up saying, for example, that the submission of this specific job has started, um, uh, it is successful, the submission is successful. And if I open the application of Altair Access, you'll see that now it is running, this one is running. And one good thing of this workflow is that, as you can see, after actually the steps that we follow is that we upload the file to the HPC, to the cluster. The file is solved there with the respective solver that we have selected, and then the result files will be stored automatically in your computer. So if I press show in Explorer, for example, and if I go to the file, you will see that all the result files are here. They are downloaded from the cluster and stored automatically in your computer. And then we can continue with DOE or optimization. And as you can see, I have defined that an output response will be the maximum stress, for example, and I create a DOE study. I will leave it as default for 40 runs. I will press apply, next. In multi-execution, I can give 10 jobs. Okay, and if I hit evaluate tasks, you'll see that um, the jobs, its input file will be sent to the cluster, it will be solved there, and then all the files, all the result files will be downloaded automatically in our computer. As you can see, I get these messages from the cluster, and I can continue solving the problems there. Thank you for watching, and I hope this video was very helpful for you.